Okay, so going over the homework questions. So starting, these are the ones that I've noticed that either people got wrong or asked me to do. Okay, so question 3. A ladder rests against a vertical wall. The ladder makes an angle 60 degrees with the horizontal, reaches a point 4 meters above the ground. Find to the nearest centimeter the distance from the foot of the wall to the ladder. So here is the triangle, okay, that we should have drawn. 4 meters high, x meters from the ladder to the wall, and it's 60 degrees. Okay, so from 60 we have our opposite and looking for adjacent, so that's tan. So tan 60 equals 4 over x. Now one or two of you did ask what happens when the x is the denominator. Okay, we don't change our approach. We multiply across by x as normal. So I end up with x times tan 60 equals 4. Now, normally the x might be here. I could just do whatever x is times tan 60. But because I'm actually looking for x, now I need to do one more step and just divide both sides by tan 60. Okay, so if the x is the denominator, there's one extra step. Okay, so calculator. Over tan 60, close your bracket, and it's to the nearest centimeter, so that's 2 decimal places, 2.31 meters. Okay, so that's question 3. Question 6 then is the next one. John is standing on a cliff and observes a boat drifting towards the base of the cliff. He decides to call emergency services and give them the position of the boat. He measured the angle of depression from the boat of the cliff to be 30 degrees, and he knows the cliff is 200 meters above sea level. How far is the boat from the cliff? Give your answer to the nearest meter. Okay. So here's the triangle. Okay. So angle of depression is from the horizontal down is 30 degrees. Now, if you look at the triangle, I either want to know this angle or I want to know this angle. There are two options. The first option is that this line is parallel to this line, which means these are alternate angles. So this is 30 degrees. The other option would be to take this angle here as 90 degrees together. So that would make this one 60 degrees. It is up to you which you take to, okay? If we take the 30 degree one, we're going to use tan, okay? So tan 30 equals 200 over x. Multiply across by x again. X tan 30 equals 200, and then divide by tan 30. X equals 200 over tan 30. Apologies, getting a bit squashed there with the next question. So 200 over tan 30 is 346.41, so 346 meters. Okay, I'll go through the other way. If we took the 60 degree, we would have opposite and adjacent this way. So it'd be tan 60 equals to x over 200, multiply across by 200. 200 times tan 60 equals x. So 200 times tan 60 is the same, 346.41, so 346 meters. Okay, so two options. When you have the angle of depression, you can take the alternate, or that this angle is a right angle. Okay, question 8. Alan wants to know the height of the tree in his back garden. Standing 5 meters from the foot of the tree and using a clinometer, he measured the angle of elevation. Now, angle of elevation is up, and angle of depression in this question is down. Okay, if Alan's 170 centimeters in height, find the height of the tree. So here's the picture. Now, it's a very crude picture of him. So the angle 33 degrees is being measured from his eye line, or at the top of his head, as we imagine. So that means whatever we find h to be, there'll be another 1.7 meters here. So what we're going to do is we're going to use this triangle to find h, and then we're going to add on Alan's height. Okay, so again, I'm using tan again. I'm using h as height, okay, not for hypotenuse. I'm using h for height. You can use x if you want. It's opposite. 5 is adjacent. So tan 33 equals the height above Alan over 5. Multiply across by 5. So 5 times tan 33 is 3.25. Now, again, remember, Alan was 1.7 meters above the ground. His head is. So the height of the tree above Alan is 3.25. So we have to go 3.25 plus his 1.7 meters, which is 4.95 meters. Okay, very common question. I think one of the higher level questions was that as well. Okay, last question from the ordinary level, and then we'll have a quick look at the higher level ones. Okay, we have this football field. Football pitch ABCD shown. During a training session, the coach asked each player to run from A to C and back to A. The pitch is 120 meters long and 90 meters. Calculate the distance covered by each player during this exercise. Okay, so we're looking at the diagonal here, running to the diagonal and running back. So we need to find the length of the diagonal and double it. Okay, if I ignore this half of this rectangle, I have a right angle triangle. I have 90, I have 120, I'm looking for AC. So this is actually Pythagoras' theorem, where AC, if I call that x squared equals 90 squared plus 120 squared. Okay, 90 squared plus 90 squared is 8,100. 120 squared is 14,400. Add them together, 22,500, and so x is the square root of 22,500. I think that's going to be 150. It is. So it's 150 meters, apologies, 150 meters from A to C. So twice that is 300 meters.